we're starting off chapter 5 by talking about the natural log function and taking the derivative of that. So let's first off, let's look at the definition of a natural log function. If we look at the definition, it says a natural log equals the integral from 1 to x of 1 all over t. Well, we know if we take the integral of a function, we're going from the function's derivative, and we're getting it back to the original function. So what we actually find out from this definition right here is that the derivative of the natural log of x is just 1 all over x. And we'll get to more of that farther down the line here. Let's just start off by looking at properties of the natural log function. All right. So the domain is going to be from 0 to infinity, and the range is from negative infinity to infinity. Let's go ahead and look at a graph of this function right here. Here's my x, my y, my origin's right here. Notice it'll never cross the y-axis there, so our domain is going to be from 0, and it's going to go all the way to infinity, all right, positive infinity. And the range is going to be, can go down all the way to negative infinity and go all the way to positive infinity, so our range is from negative infinity to infinity. It's 1 to 1, which means for every x, I have a y value for y. It's increasing, as you can tell. It's moving up, all right? And then it's also concave down, all right? So let's continue to look at this stuff here. It's continuous, increasing 1 to 1. I said all that stuff. Concave down, you bet. All right, so more properties of a natural log function. The natural log of 1 is 0. If you go back and you look at our graph, if we find 1, right here is 1, that's going to be 0. All right, that's what it says 1 right up here. So the natural log of 1 is going to be 0. That's a property that we know. So anytime you come up with a natural log of 1, you're going to find 0. It's going to be 0. All right, another property we have, if we're multiplying inside the natural log function, it's going to be that we can break that into two functions, the natural log of a plus the natural log of b. So we broke this into two functions instead of just one. If we have a power inside the natural log function, we're going to bring that power down and write it on the outside. And if we're dividing, we're going to subtract instead of add. It's the opposite of multiplication. So we're going to take the natural log of a minus the natural log of b. So just some examples here and getting us used to working with the properties of natural logs. All right, we're going to simplify the natural log of 10 all over 9. So we just said that we can take the natural log of 10 and subtract the natural log of 9. That makes it much easier for us to evaluate on a calculator or whatever we're using. All right, and how about for b? Well, we can rewrite this as 3x plus 2 to the 1/2 power. Right? That's what the square root means. So the natural log of that means that to simplify this, we can bring this 1/2 down. It'll be the 1/2 times the natural log of 3x plus 2. And we can't do anything with that 3x plus 2. That's all one function together. Okay? So, and then for c, we have, let's scoot it up here a little bit. Anyway, another example. So let's go ahead and we'll break it in division first. We can get rid of this fraction first. So we take the natural log of 6x minus the natural log of 5. All right, well, we can also break this guy down because it's multiplication. We have 6 times x. So we can break this down into the natural log of 6 plus the natural log of x minus the natural log of 5. And this last one here. All right, let's go ahead and let's break it into two functions. Get rid of this division bar first. So let's say the natural log of x squared plus 3 squared minus the natural log of x times, I'm just going to go ahead and write it, x squared plus 1 to the 1/2 power right now. Okay? So we can continue to simplify both of these now. We can look at these each separately. We can simplify this. Yeah, we can bring that 2 and bring it down. That was one of our properties. So let's go 2 times the natural log of x squared plus 3. Minus, then we can break this down. This is multiplication. So we can break it down into two separate, into natural log of x plus the natural log of x squared plus 1 to the 1/2 power. Well, again, we can still, so we can't do anything over here yet, but we can still simplify here, all right, by bringing this 1/2 down. And the only thing left to do then is to multiply by bring our negative through, all right? So let's rewrite this, 2 natural log of x squared plus 3, and bring my negative sign through. So minus the natural log of x minus the 1/2, so I'm bringing my 1/2 down, natural log of x squared plus 1. Okay, so that's simplifying that for us. Now the derivative of the natural log, we kind of hit that already up there in the definition of the natural log. All right, and what I like to call is what is it going to be the derivative of stuff over stuff. All right, when I'm talking about stuff, I mean this stuff inside here. And like we said up there in the definition, it said the natural log of x, its derivative was going to be 1 all over x. Well, my stuff is just x. The derivative of x is 1. So here's the derivative of stuff all over the stuff we started with. So that's why I say stuff over stuff for the derivative of natural log functions. Okay? So in this case, our inside, or our stuff, is going to be 2x. The derivative of 2x is just 2. So derivative of stuff all over stuff. That's all. That's our derivative. All right? Same thing down here. My inside, my stuff, and the inside is x squared plus 1. So my derivative of my stuff is just 2x all over my stuff, which is x squared plus 1. That's it. That's the derivative. It's a lot easier than you would have thought it would have been when we first started. Okay, now our same derivative rules apply here. All right, we're still multiplying two functions, so we still have to do the product rule in this case. All right, and the product rule says the derivative of the first one times the second one. So the derivative of x is just 1 times the natural log of x, right? Plus the first one times the derivative of the second one. Well, the derivative of the second one is just the derivative of stuff over stuff, which is 1 all over x. And these end up canceling out. So we have the natural log of x plus 1 is that derivative there. Okay? And lastly, again, the same rules apply. Looks like I have a function inside of a function, so I need to do the chain rule. All right, I need to take the derivative of my outside, leave the inside the same, and then multiply it then by the derivative of the inside. So my chain rule says I need to do the derivative of the outside first. All right, so 3, leave the inside the same, natural log of x, and subtract my power by 1. And the chain rule says then I need to multiply it then by the derivative of the inside. Well, the derivative of the inside is just natural log function, which is just derivative of stuff over stuff, so 1 all over x. So our derivative then is going to be 3 natural log of x squared all over x. I believe that's it for this part of the section. I hope this stuff helps, and we'll see you in class.